let you know more about the code of conduct, I will hand it over to Chintan.
Okay, thanks for the introduction, Rohan. Happy weekend, everyone. It's good to see you back after, like, for the session after a very long time. Like, even for our online meetup, we were on a break, so we are coming back. So thank you everyone for joining. So before we get started, I would take a moment to share our code of conduct. Like, since we are all here for learning something and for a session, so we are here to enjoy the talk and let's others enjoy it as well. And since we are engineers and very curious people, and we hold our strong opinions about different things and different stuff. So if there is some disconnect between your opinion and what we are presenting here, please write it down in chat. But please don't interrupt the session while the speaker is talking or sharing something. Also, it's important that you don't fight or create dispute in the chat with each other, like harassing people based on gender, age, race, religion, or any other XYZ reason. This won't be tolerated. And lastly, success of this event most rely on you to be a good listener. So relax and enjoy the session and note down the details, whatever is present. And for any questions or any feedback you have, so any questions you have, we'll share the link for the Slido, so you can put down your questions there. The speaker will take up all the questions at the end of the session, and for the feedback, we'll be sharing a link at the end of the session. And for any other details and also to know about more about the code of conduct, you can visit our kotlinmumbai.org website and you can get the more information. So yeah, you are everyone, you are here for the session. So let's start about the session. But before that, let's introduce our today's speaker. So for that, I will hand over to Shreyas.
Cool. Hi everyone. So let me introduce you to the speaker of the session. So today we have Bhavna with us. So Bhavna is a freelance Android developer or consultant. She is Women Technicals member, Android Tech editor or video code instructor at Ravenderlich. She is also a YouTuber and have her own YouTube channel called Learn Android, where she regularly upload tech tutorials on Android and Kotlin. When she is not at work, you can find her in kitchen listening to music and experimenting new dishes. So that's all about Bhavna. So before moving that, I will hand over this to Rishit. So Rishit.
Sure. If you want to ask any questions while the talk is on, feel free to go to slido.com, enter the code KTMUM, and put in any questions you have. We'll relay them over to Bhavna at the end of the talk, and she could probably answer them. Also, you don't require any kind of login, and yeah, you can also scan the QR code if that's more easy for you. So I'll keep this on for a second or two. Uh, the code is KTMUM, and you go on slido.com and start putting in any questions you have. We'll also put a direct link to the slide to slido.com in the chat. So if that's easier for anyone, you can directly get it from the chat. Now all over to Bhavna, and yeah, please feel free to share your screen too. So
Bhavna,
Bhavna,
you're
you
not.
are
Am I audible or on mute? Or that's a little, that toggle is fluctuating a bit.
Yeah, you are audible, Bhavna.
Okay. Mhm. Okay. So, good afternoon, everyone. Today's session, we're going to discuss about Jetpack DataStore. So my introduction has already been given by Shreyash. So thank you, Shreyash, for that. And so I'll not go in detail. Let's start with agenda. What we are going to discuss today. So we'll start with what is Jetpack DataStore. We'll see the introduction of its two different implementations, preferences and Proto DataStore. We'll compare shared preferences with DataStore, and we'll also discuss why it is wise to migrate to either of the implementation of the DataStore. We'll compare DataStore with Room and discuss scenarios when to use each. We'll see Android Studio demo of how to add Proto DataStore to your Android app, how to read and write data using it, then how to migrate from shared preferences to Proto DataStore, and how to inject a DataStore dependency via Hilt. So let's start with what is Jetpack DataStore. It's basically a Jetpack library that provides data storage solution for smaller data sets, such as your shared preferences or application state. It's a preferred replacement for shared preferences. So if you are using shared preferences in your app at present, you can consider migrating to DataStore. This is very important. It uses Kotlin coroutines and flow to store the data asynchronously. That's the keyword, asynchronously, transactionally, and consistently. And you have two implementations of the DataStore, preferences and Proto DataStore. So we'll see about each of this in detail now. So what are preferences DataStore? They save small primitive data in key value pairs. Now this implementation does not require you to define any predefined schema, but it does not provide you type safety as well. Proto DataStore, on the other hand, saves small typed data backed by protocol buffers. So for this particular implementation, you have to define your schema using protocol buffers, and it provides you the type safety. So we covered what is Jetpack DataStore, and now we cover why use Jetpack DataStore. What are the problems with the existing shared preferences? So what are shared preferences? They save small primitive data in key value pairs. They provide synchronous API, there is full support. And how do you get shared preferences? You call context.get shared preferences. Then we say shared preferences.edit. So you call edit on them. And then you have some value which could be like string, integer, boolean. So you like call the method like put int, put boolean, put string, put integer, etc. You attach a key to the value, and that is how you put the data. Here comes the first problem, type safety. This mechanism of key value pair does not provide you type safety, right? Because system doesn't know that what you have put in the key. I mean, so if you put a string and then say get integer or boolean, you're going to get exception. So this is the first problem. Let's see the other problems. Once you put a string or boolean, you call editor.apply or editor.commit to save the values. Now, under the hood, apply changes data in memory immediately and on disk asynchronously, and commit is going to save the data on disk synchronously. So think about if you use apply, there is no data consistency, right? Because in memory data is changed immediately. On disk, it's going to be changed asynchronously. We are talking about persistent data storage, and persistent data storage itself, we are not getting the consistency of the data. So this is one of the major problems. You think that you get an asynchronous API support using apply, then that is partially true, because when you call apply, it internally makes calls to Fsync, and it blocks the UI thread on Fsync. Now this Fsync calls are triggered whenever an activity service starts or stops in your application. So again, full asynchronous API support is not provided by shared preferences. There are other problems as well. They have no mechanism to signal errors. They are not safe from runtime exceptions. So if there is any error while parsing the data, reading from shared preferences files, it could lead to runtime exceptions. And there is no inbuilt migration support. So suppose you want to make a simple change, like if you have a Boolean preference in your application right now, a key which is a Boolean. So it will have two values, true and false. And now you want to support a third state in the, say it is not set. So if I want to support a third state, maybe I want to migrate the key from being Boolean to an integer so that I can support it third state as well. That all you have to do it manually to migrate from old shared preference to new. But there will not be any, there is no any inbuilt support for migrations. We'll see that in DataStore. DataStore actually provides migration support. From shared preferences to DataStore, you have the migration support, and from DataStore to DataStore as well. So that makes your life easier. With less code, you can do the migration. So this is the summary of what we've discussed, shared preferences versus DataStore. As you can see, the major advantages of DataStore is like it comes with full support for asynchronous API, with error handling, with data consistency and migration support. And if you want type safety as well, you go for Proto DataStore. Now, comparison of preferences DataStore with Proto DataStore. Data structure in preferences DataStore is key value pairs, whereas in Proto DataStore, it is your predefined schema using protocol buffers. So if you are looking for a very quick shared preferences migration, you can go for preferences DataStore. However, if you have some complex data like enums or list in your data, you can go for Proto DataStore, where you get an additional advantage of type safety as well. So now let's see DataStore versus Room, when to use each, because both of them provide you a persistent storage on the device, right? So you might have a question whether I should use Room or should use DataStore. So if you have large data sets, if you require a referential integrity, now referential integrity basically refers to relationship between the tables. So if you have more than one tables and a primary key in one table is like acting as a foreign key in the next table, and you have a lot of relations between the tables, you are querying the data, and that too with complex queries, or if you need partial updates. In all these scenarios, you consider using Room instead of DataStore. However, if you have a very small and simple data set and you're doing very simple read and write operations without complex queries, you go for DataStore instead of Room. If you're still confused whether to use DataStore or Room, I'm taking an example from an app at my GitHub repository, Jettask. I recently published this app on the GitHub as an open source project, and it's a part of Google Dev's library project as well. You can check this out after this talk. So it basically demonstrates modern development of best practices. And in this app, what we're doing is like user can create a task, and it saves the task list and task details in the Room database. So for task data, I'm using Room. And DataStore, you can see the bottom part of the screen. You can filter the task by show completed flag, and you can sort the task by priority or deadline or both, so that user's preference and saving it in the DataStore. So this is how you can. This is one example where you understand when to use Room and when to use DataStore. Now let's look at some design considerations when you use Jetpack DataStore. So I'm taking the example from like experience. Last month we had during the code review. So we had this customer app, and on the login page we had this domain and remember domain on the UI, and we thought of using Proto DataStore to save the domain and remember domain. So domain is to be saved when user checks the remember domain. What a developer did is he used a single string in the data, and then he had to write a very complex logic to determine whether this remember domain was checked or not. So if the string is not empty, if it contains the value, that means remember domain was checked by the user, and vice versa, etc. So what we concluded is, instead of doing something complex between UI and data, when you are designing this kind of data store, you try to have one is to one mapping between UI and data. So what you see on the UI, if you see a text in the UI through edit text, etc., you save use a string in the database, and if you have something like checkbox like remember domain, you use a boolean. Then your life becomes easier, right? So that way, like this was one learning that I wanted to share from like real-time experience. Now I think we have covered enough of theory, and we can now go to demo to understand the data store. Before I jump on to demo, this is what will be covered in the demo, so I'll just mention that. In the demo, we are going to see how to add Proto DataStore to your Android app, how to read and write data using it, how to migrate from shared preferences to Proto DataStore, and how to inject data store dependency via Hilt. So you guys can see my studio screen, right? Android studio screen?
Yes.
Yeah, okay, great. So for demo purposes, I'm using Jettask app from my GitHub repository. And from master branch, what I've done is I've tweaked the code to make it ready for the demo. So even after this talk, if you want to refer to the code, what is going to be demoed today, there are two branches, Proto DataStore starter branch and Proto DataStore final branch. So starter branch is from where I'll be starting now, and final branch will have the code at the end of this demo. Okay. So you can see the emulator open on my Android Studio, and you can see a list of tasks. We can add a new task from here. So I'll just walk you through the app. You have the filter which will show completed task only if it is on, right? We can sort the task by priority and deadline. Now in the starter code, what I have done is we are saving the sort order in shared preferences, our traditional way of saving the data. And this show completed flag, we are not saving anywhere. So what will happen if I exit the app and if I launch it again? You can see the sort order is maintained because it's saved in the shared preferences, but show completed, it was turned on, it was only in the memory, so it was forgotten, right? In the demo, what we'll do is we will migrate this sort order from shared preferences to Jetpack DataStore. We'll use Proto DataStore implementation, and we will add this show completed flag as well. So everything will be part of that Proto DataStore schema, sort order and show completed Boolean flag, right? And yes, this much like this is the brief introduction about the starter app, and you can see the package structure. So your main two packages, UI and data. So UI is built with Jetpack Compose, and data layer, we have two important repositories. The task repository, which will take care of saving the data and getting the data from room database. And I have user preferences repository, which at present gets the data from shared preferences. I can show you this user preferences repository implementation, we defined the sort order key and sort order here. Then we get the shared preferences. We get the sort order. And whenever user tries to change the sort order, we have two functions: enable sort by deadline and enable sort by priority. And we have this update sort order, which is going to edit the shared preferences. See, if I go to this edit function, this is pretty slow today. Wait. So basically, edit will be a lambda block where if you say commit equals to true, it will do edit dot commit, else it will do edit apply, right? Editor dot apply. I'm trying to show it with that box. Okay, no issues. So this will be the starter code, and now we start today's demo. The first thing that we want to do is adding the dependency for Proto DataStore. So for that, we go to app modules build.gradle. And here we add Protobuf plugin. So I'm going to use Android Studio Live templates. So at the top of the file, we are adding the Protobuf plugin. We need this because we are going to add Proto DataStore. Then in the dependencies section, we are going to add dependency for Proto DataStore and protocol buffers. So we have added DataStore core and DataStore dependency and Protobuf dependency. We also have to configure the Protobuf. So we added the plugin for Protobuf, and this mentions the repository, and this mentions what will be the output for the Protobuf. Like it will generate the Java Protobuf Lite code, as we have mentioned the output format as well. So these three dependencies we added. We have configured the Protobuf. We have Protobuf and Proto DataStore dependencies and plugin. With this, we are now ready to use Proto DataStore. So the next step is define the schema using protocol buffers. I think many of you would be new to protocol buffers. So what I'll do is I want to open a new tab. Okay. Yeah. So we go to the official documentation on what are protocol buffers. They are Google's language neutral, platform neutral, extensible mechanism for serializing structured data. So they are like protocol buffers are like you can say a language similar to XML, but still smaller, faster, and simpler. And the advantages that you can first define your schema once, and then you can generate the source code in any of the languages that you like Java, Python, Objective-C, and now with this Proto 3 language version, it supports Kotlin, Dart, etc. So how do you define a schema using protocol buffers? If it's Kotlin or say Java, what we say it's class or data class, right? So in protocol buffers, you say a schema, define the schema using the keyword message. Then say I want to define a person schema. So message person Then you have its fields, whether it's required or optional, then type of the field, string, integer, boolean, and you need to give a unique integer to each of the fields. That basically helps in the serialization. So internal encoding and decoding, this is used. This block explains how do you set the values and write to the output stream, and how do you read it. So this we will see in the Android Studio while we define the serializer. So I just wanted to give you a brief on what are protocol buffers. And now for our starter app, we are ready to define the schema using protocol buffers. So for that, what we'll do is we create a directory, proto directory under app src main. So under the main folder, create a new directory, proto. Inside proto directory, create a file user underscore prefs dot proto. Here I'm going to define the schema that we will be using it for our app. So what do we need in the schema? We need a boolean flag for show completed, and we need sort order, right? So let's first think about the schema. You have show completed task is a boolean, and you have a sort order. Sort order, say suppose you will not define the sort order, so it will be none, then by priority, by deadline, and by both. So sort order will be an enum. Now we can enclose this entire thing, combine this entire thing into one schema named user preferences. So I will call it user preferences. And my protocol buffer file will look something like this. Syntax Proto 3, we just now saw that Proto 3 will support Kotlin language. Then you specify option Java package. So when we are going to rebuild our project, the compiler is what internally it's going to happen is it is going to create a Java file for this particular user preferences, and it will convert this into the schema into a class user preferences. So using Java package, you specify where you want to the package where you want to have your user preferences class. And this particular line, Java multiple files true, will tell it that if there are more than one messages in the same file, whether it should generate a individual file, Java file for each of the messages. Okay. Then we define the schema using message. So first is boolean show completed and sort order. And sort order is as we discussed, it's a enum, and it has some values. You can also see one more value, say none was already there, unspecified we have provided. This will help us in migration. So when we are migrating it from the shared preferences to Jetpack DataStore, we will use this value for migration. So I'll show you when we reach migration. So this is how we define the schema. Once we define the schema, what we should do is rebuild the project so that the corresponding Java files are generated and we can use it. So I'll wait for the project rebuild. Hope it generates with the rebuild only. Sometimes we face the issue that we have to invalidate caches and restart the Android Studio for it to generate. So hope it respects our demo and it does it.
So, what you said sounds like a great idea. So, I think I heard an echo, but okay. So, while we wait for the Gradle build to run, would you be up to take some questions?
Yes. Yeah, sure.
So, I'll just share. I'll just share my screen. I wasn't prepared to do this, so give me a moment, and I'll just get it. Just starting up the question screen. Give me a moment. Okay, here it is. So while the demo takes some time, we'll just relay some questions over to Bhavna, and we have quite a few questions. The first one is when migrating from preferences, what would be the best way to convert sync APIs to async? What to do when we require data synchronously?
Okay. Can you come? You've shared your screen?
Yeah, I've shared my screen. Is it visible?
Not yet, I believe.
Bhavna, it is visible for me. Can you reach it?
Okay. Yes. Now it's visible. Okay. KPI is to async. What do we do when we require? Okay. See, basically, what is preferred in data store is use async APIs. So if you refer to the official documentation, they also suggest that you don't go for synchronous APIs. Okay. So see, best way to, you don't have to convert actually. What we are using in shared preferences, if you are using commit, then it is a synchronous API. If you are using apply, it was partially an asynchronous API with under the hood fsync calls would be synchronous, and then you migrate to data store, it is fully asynchronous. So they are recommending us to use asynchronous only. But if you have something like a strict requirement that you want to go for synchronous only, then you can have it wrap it around a run blocking code. So it's flow, right? When you say data store or data, it will be Kotlin flow, and that you can get the data inside the run blocking code as asynchronous API. But what they are suggesting is you get the asynchronous data before in hand, and don't run it synchronously. I mean, only if there is a strict requirement. Why would you require data synchronously? Like in the other data, if you say room or retrofit, we fetch asynchronously, right? So you can go for this as well asynchronously, and then if you have multiple flows, you can combine them and then listen to when the flow emits or changes, gets the new data.
Okay, that makes sense. The next question is, since data store uses protocol buffers, how much difference should one expect in terms of storage requirements?
Storage requirements, protocol buffers. I don't think there would be much difference in terms of storage, because anyways, this shared preferences or protocol, this data store would be in terms of KB, very small size data, right? So I don't think that would be much difference. But again, it depends on your real world application, how much you are saving the data in the data store. And again, if it's getting huge above the limit, it's a signal that maybe you should migrate it to room rather than using data store, right? So
Yeah, that makes sense. And this would also be a really nice exercise to do.
yeah.
Also, like, do feel free to stop the questions whenever the Gradle build is completed.
Let me just check if it is done. I'll have to restart my studio so we can take up the questions.
Sure, sure. So the next question we have is SharedPreferences is a part of framework or Android SDK, and DataStore is a part of Jetpack library. Can DataStore be part of the framework?
Can data store be part of the framework? So right now it is like a Jetpack library, right? So you include it as a library. Not sure in future they are going to club it, or maybe it's a part of library for now. So not sure on this.
Okay. The next question is how DataStore preferences differ from shared preferences. Like shared preferences to data in XML, what does DataStore preferences do under the hood? I think you covered a lot of this, but
Yeah.
just if you could give us.
See, don't confuse with the name. Shared preferences and data store. Even if preferences data store, it's a completely async API. Okay. The only similarity between both of them would be the key value pairs. Otherwise, preferences data store will give you all the advantages, which were the limitations of shared preferences. Now, talking about the saving of the file, they save the file to disk. Yes, it internally uses protocol buffers, but then it makes a wrapper around to have key value pairs. I think it is XML file. I can confirm you with this because in the Proto Data Store, it is protocol buffer file. Uh, Here it is XML, but I'll confirm.
Got it. We also have a question from the chat. Before taking the next question, I'll just put it up for you. We have a question in the chat by Aniket, and he asks, what's the size increase of adding of the app itself, adding the type data store library?
Uh, we'll have to check it out. Not sure, but I don't think being a part of Jetpack library, it's going to increase it to that extent. So, and we can compare. See, what we are going to cover in today's session is using Proto Data Store using protocol buffers. So, if you don't want to go for protocol buffers, you have one more way of adding Proto Data Store by using Kotlin data classes and serialization. So I'll at the end of the talk, I'll share resources with you where you don't have to use protocol buffers. And that is also a way, I mean, of doing this.
I again think this would be a really nice and interesting exercise. The next question we have is by Rohan, and he asks, what is the minimum API level support for data store?
Okay. Minimum API level, I don't think there is a limitation. But yes, because it uses Kotlin coroutines and flow, uh, it will work with code bases where Java is mainly used. No, because see, it uh, it is built on the top of coroutines and flow. So basically, Java it will not work.
There is another related question about this. Let's say our production app is still using Java. Can we still do something to leverage all features of data store?
Again, this is similar question. At this point, I think no, but I note down this question. I'll get back to you on this. We'll have to also research on this if it's Java, what we can do, because it's everything in Kotlin, right? So
Okay, the next question is how would you handle larger messages since protocol buffers don't allow random access?
Would you handle larger messages since protocol buffers don't allow random access? Larger messages, in case, I mean, what actually I'm not getting the question. Larger messages as in, see, messages would be a schema, right? So does it mean the schema is longer or more, like in terms of volume, you're saying?
Yeah, probably the author of this question type in a clarification, a more specific question that would be.
But what I would suggest, yeah, what I would suggest is if you have a requirement of random access, or if you are querying it that way, complex queries and all, then your the decision to go for data store would not be wise. Maybe you could go for room then, right? So because it's very small, simple data sets that you want to share preferences, you will go for protocol buffers, right? Like,
Yeah, that makes sense. The next question we have is what is max limit of storing data in XML preferences versus protocol buffers?
max limit. I note down this question, but my apologies, not aware of it right now. So,
Sure.
like whoever is asking the question and I'm saying get back to you, please connect with me on Twitter and I'll definitely browse, explore and get back to you with the, a feasible answer for that. Yeah.
Oh, I by mistakenly marked off one question, but the question was the performance differences between shared preferences and data store.
Performance differences. See, data store, what I've read is, see, you don't experience much difference, but uh, the way it works, data store, it does atomic read, modify, write operation. When the entire operation is only complete, the coroutine is said to be completed and it will emit the new value. So that entire transaction being atomic, it will be little slower than shared preferences. But on the other end, it's going to be asynchronous, so it is not going to block your UI thread, right? It's completely non-blocking operation.
Yes. The next question we have is by Zeus, and he asks, is there any way to encrypt data like encrypted shared preferences?
Encrypted data. Uh, right now, whatever I have read about data store, no, but I can check and get back to you. Yes.
Sure. So the next one we have is data store. I'll just put it in correct words. Data store will be supported by Kotlin multi-platform.
Again, no clue on Kotlin multi-platform for data store. I just noted down the question.
Sure. So I think you already answered this question, so we'll go right past this one. And the last question we have as of now is data store possible with RX Java?
Again, I think if it's we have to again check the Java compatibility. So RX Java and Java both. Yes. So again, I have also noted down this question.
Sure. So those are all the questions for now. I'll stop sharing my screen, and if the Cradle build is completed, we could probably continue the demo. All up to you.
So I restarted the Android Studio. So sometimes you have to do it for this schema to be generated. Rebuild may not work all the time. So we've restarted the studio and emulator as well. We have to just start it. Okay. we just start and keep it ready. We may not need it right now. Okay. So now if I search for user preferences class, you can see user preferences.java. So this is what I was telling you. You have to rebuild the project or required or restart the Android Studio for this class to be generated. As you can see, this is generated with the package name that we have specified, and inside it, it will have the enum sort order and boolean show completed. Okay. So with our, so we are now done with defining our schema. So just to recap what we have done in the demo, we have added the library, and this next step, we have defined the schema. Now we have to tell the data store how to read and write the data. Okay, so you from the protocol buffer. So for that, we have to define a serializer. So what I'm going to do is under the repository package, create a new file, call it user preferences serializer. Emulator, I can hide it for now. So here we specify the serializer. The light templates also taking time to come up. Okay. Yeah. So you need only one instance of serializer, so you call it object, and it is going to extend data store.core.serializer with our schema user preferences class, right? You have to override the default value, and then we have to override two methods, write to and read from. So this read from will basically convert an input stream to your user preferences object. Okay, so when you're reading the data, you read from the input stream and you get the user preferences object. And when you write to, you do the other way around. You convert your user preferences to the output stream which is written. So this is the serializer which will work in between. And when we are creating the data store instance, we have to mention what is the serializer we are going to use. So that time we will mention this serializer. So now we are ready to create the data store instance and read and write data using it. For that, we are going to make changes to repository. See, this is sort order. Now it will be changed to user preferences, right? So I rename this to user preferences flow. And this sort order, I update it to user preferences. Now we return to user preferences repository implementation. The sort order we have already defined in our schema, so we don't need it now. I'm going to get rid of it. Then shared preferences, we just delete them because we are migrating. The sort order, this is also, we don't need it. This getting of sort ordered from shared preferences, this also we don't need it. Now, first thing we need to do is get an instance of data store. Okay, so again, live template I'm going to use. With screen share, this is very slow. Why it is not coming up? Yeah. So you define, let me first import it. Import user preferences. You use a DataStore delegate to get the instance of DataStore, and it has two parameters, file name. So you specify DataStore file name. This will be your user preferences dot protocol buffer file, and your serializer. Okay, so we this best practices for DataStore tells you that you should create only one instance of DataStore for your one file. So if you create multiple instances, your data might get corrupted, or and so we'll use only one instance. And in your production app, it is advisable to use Hilt, so that if you use dependency injection with Hilt, and if you provide a singleton instance from there, all these problems are solved. So at the end of the demo, we will see how to migrate this dependency to Hilt. Right now, we'll work with this. So inside the user preferences repository, I get the access to user preferences store by defining a variable here. Okay, so you see user preferences store equals to context dot user preferences store, because it's a receiver of this is part of context, type context, sorry. So you get the access to user preferences store, and then this line is important, 35, line number 35. How do you read the data from data store? You call datastore dot data, and as we discussed in the slide, it will provide you data, Kotlin coroutines and flow. So it will provide you flow of user preferences. And as we discussed, it has mechanism to catch exceptions. So you can use catch flow operator. If there is any exception, it throws IO exception while error encountered in reading the data, it's going to catch it. See, all this facility you have, if you've used shared preferences, you understand this was not there. So we defined the data store instance, and we have done reading the data. If there is any error, we are catching it as well. Now, how to update the data? So how to write the data? This earlier implementation of shared preferences, I'm going to remove. And whenever user presses like enable sort or disable sort by deadline, how will you update the data? That we'll see now. Live templates are pretty slow in demo. Yeah. Enable sort by deadline. So you use datastore.data to read the data. You use datastore.update data when you want to modify the data. So it will give you first the current preferences, and you define the new sort order. So this will be your logic based on your application. So in our application, we have sort by deadline and priority both, right? So if you want to enable sort by deadline, we first check if it is enabled by priority as well. Then you enable by both deadline and priority, else by deadline. If it is to be disabled, we have to remove the sort by deadline from the current order. So you first get the data, then you set what the new data that you want to set it, and then this line is important. Current preferences dot to builder, so it opens up your current data for modification. Set sort order to new order dot build. So this way you update the data, and this entire operation is like atomic read, modify, write, and then when the entire coroutines completes, this flow will emit a new data. So similarly, we can enable sort by priority by using Proto DataStore. This will be similar, so we will skip the explanation for this. Okay, it came. Enable sort by priority. Okay, this is pretty similar. Here we are updating the sort ordered by priority. And this was the earlier piece of code to update sort order using shared preference. We don't need it because sort order is now updated here itself. One thing we have to do is that show completed flag. This user preferences, okay. Show completed flag, we were not saving it in the database. So now we want to save it. We have to support a function for this. So I define a function update show completed. Whenever user toggles that switch, we will implement the function here. No, this is the definition. Okay, you call datastore.update data and you say set show completed to whatever user has given true or false dot build. So this completes the repository where you're using the data store to read and write the data. Now once we are done with repository, we go for a view model. Inside view model, we'll make few changes. First is the sort order. Sort order will not be in the repository now. It will be in the user preferences. It should show in red, but anyways, we have to update it. Okay. Then the sort order flow is now user preferences flow, right? So we have combined sort order and show completed inside a user preference. So I'm going to refactor, rename this to user preferences flow. Show completed flow, we don't need it because everything will be inside user preferences. Task UI model flow. This was basically combining three flows, your all the task, then user preferences, and then show completed was different, but now it is combined in user preferences. So we just get rid of this third parameter in the combine block. So combine block will have only two parameters. So this will also be user preferences. So show completed will come from user preferences. We have taken user preferences dot sort order, right? So I think when we build this, this will go. It is there, right? Okay, user preferences we have to import maybe. Okay. Spelling is okay, yeah, it's correct. So user preferences now contains the sort order. So this parameter will also be updated to user preferences dot sort order. Now filter sort task. This is going to filter the task based on the sort order. We added one more parameter unspecified for the sort order. So we provide a support for that. Show completed task. This will be called when the user toggles the switch, right? So earlier we were not saving anything in the repository. Now we'll call that update show completed method. So you call repository.set show completed. So your whatever user's preference is now saved in the repository. And I think with this we have changed the view model. So you understand we made changes to repository and view model, which is a state holder. Now we have nothing to do with the changes in the UI layer, right? So we have not touched UI layer at all. This is how you, if you develop an app with clean architecture with separation of layers, then you will not have any changes in the in your UI code. So maybe it's like activity fragments and XML approach or Jetpack Compose UI. Your UI code will not have any changes. We just have to correct imports in couple of places. That's it. Task list has some sort order. So we just have to correct the sort order import. And there was one more UI model had the sort order. So okay. So we're done with the changes, but we have not tell our app how to deal with migration. So migration related information, where do we give it? We declared the data store instance at the top of this file. Here you can specify if when you create the data store instance, if there is an existing shared preferences file, how do you migrate? So that information you can provide here. Okay, so I'll explain the code now. You have produce migrations parameter in the data store delegate, which takes list of migrations. So you can provide multiple migrations with a list. So this shared preferences migration you can use, which is provided by data store. And so you create shared preferences migration context, then you give the name of the share user preferences file that you were using earlier, right? And inside the lambda you get hold of both the preferences, your old preferences which were shared preferences and your current data which is user preferences. So first time after migration, when you run your app, sort order in your user preferences will be unspecified. This is why we used an extra value unspecified. If it is unspecified, that means we have to migrate this from shared preferences, get the sort order and set the sort order of the current data. So it may take you some time to understand this piece of code. So you can refer to my GitHub repository. See, what we are doing is when migrations run, check the sort order. If it's unspecified, the default value, that means you have to run the migration and get the value from shared preferences and put it inside the user preferences. So this is how you take care of migrations. So with all these changes, we are done with all the tasks that we had to do it. So let's go to emulator and see the current status. So we confirm the sort order is right now sort by priority and deadline. Both of them has been set. And if we run the migration, it should be retained. But this show completed task, we were not saving it earlier, right? So when we run the migration, this value will be lost. This is only in the memory. And I want to also show you one more thing. See, where does your data reside? It will be in the internal storage data. Let's check the shared preferences file before migration. Sorry. Jettask app. So you go to search by package name inside data package name of your application, and you see shared underscore preferences. So you have user preferences.xml file, and the sort order is by deadline and priority, right? This is what your current data structure is. Now we are going to migrate it. So I rerun the app. I think should we take up questions till this runs, or okay, it's running. Wait.
So the talk is really interesting, but I just have to pitch in. We'll soon hit the 1.5-hour mark. So just a small reminder that 10 minutes are left.
Okay, yeah. We are almost done with the demo. Actually, this with screen sharing and this team meeting, the studio turned out to be very slow. Otherwise, when I did it earlier, it was to be like 20 minutes, 20 to 25 minutes, it could have completed.
Yes, that makes
Yeah.
sense.
So, and if we are getting late, I think the app will run fine basically. And what will happen is like the sort order will be maintained, migrated, but show completed because we're not saving it. That will not be saved. So that's what I wanted to demonstrate. And last step that we had was the dependency injection using Hilt. So I can quickly show you steps for that. So if you're using Hilt, then what you should do is this data store instance that we created inside the repository class. Instead of that, you tell Hilt how to create the data store instance, so that you will do it here, and then the data store will be a constructor parameter inside the repository. That way, using Hilt, you can do the implementation. So that particular piece of code, you said how much time is available? Should I demo that, or we can? I mean, viewers can use the GitHub code to understand that part, the last piece of code.
Oh, so you can take more time if you want, but ideally it would be nice if you could wrap it in 10 minutes.
Yeah, got it. So basically what I wanted to demonstrate is the Hilt dependency injection. So if you go for that, what we will do is inside the user preferences repository implementation, in the constructor, we provide the user preferences store. Let the install complete and then I change the data. Okay. So Hilt will provide you this user preferences store repository instance and data store instance, and you don't need to do it here. This this I will make it public so that and we go to DI module and app module. Basically here we provide the data like instructions to Hilt as in how to generate the data store instance. So here you provide user preferences repository and data store instance, and you have to tell Hilt how to get the data store instance also. So here only the other method will also come. So this is similar to the data store instance that we had done it in the class. Here we use datastore.factory instead of delegate, and the other parameters remain the same. So this will work, just imports we have to do it. Okay. So Rishit, I think we are done with the demo. And if anybody has any questions, and if the time permits, we can take it up.
Thank you so much, Bhavna. And I wish we could go on longer. This is really interesting. We don't have any questions at the moment. Thanks to you for taking all of this up. And I'll ask Chintan to go ahead.
Yeah. So thank you once again, Bhavna, for this wonderful session where you demonstrated about yeah.
Yeah, thanks a lot. Even I enjoyed talking here, and these are the references. I just missed it. So
Yeah, sure.
references, yeah.
Okay, so yeah, guys, we had that reference. Also, these are the social handles of Bhavna. So if you, in case you have any doubts or maybe some questions, if you have still pending from your side, then you can ask her directly. So you can reach out to on the Twitter handle, or maybe you can visit the website. So we are thanking once again, Bhavna. Thank you for this session, and thank you everyone for joining us on the Saturday weekend and learning together this wonderful topic. So thank you everyone from Kotlin Mumbai team. And for the feedback, we would be rolling out a form. So whenever you get the link, please fill it up. And yeah, that's it. Thanks again, everyone, and see you in the next session.
Yeah, thank you.
Bye, everyone.